Rise and shine, Educalidad! Great morning, students and dear listeners. Welcome to our class on air here in DXVD 101.3 FM. This is Teacher Sherry May from the Pitan City National High School for Grade 9 Science lesson for the week 1 of November. Grade 9 students, are you ready? In this session, let's study the effect of temperature on the speed of sound. But before that, let's review what sound is and some important details. What is sound? Sound is a form of energy produced when matter vibrates. It is a vibration of kinetic energy passed from one molecule to molecule. Since sound energy is a product of molecular collision, which we call vibration, and is passed from one molecule to another, it means sound moves in the presence only of molecules or particles. Thus, sound cannot travel through a vacuum just like the outer space. What is a vacuum? A vacuum is a place where there is nothing, even a single particle. Sound does not travel in a vacuum due to the absence of particles that act as a medium. So, if you were in outer space and you saw a huge explosion, you hear nothing because the sound cannot travel in an empty space. For sound to propagate, it needs a medium which can be solid, liquid, or a gas. This is the reason why sound is considered as mechanical wave, because it transfers its energy through a medium. When we say medium, it means a substance through which sound travels, which can be solid, liquid, or gas. When object vibrates, it gives energy to the particles of matter around it, and the energy travels to our ears and is interpreted by our brain as sound. How does sound wave travel in different media, such as solid, liquid, and gas? Sound is a longitudinal wave when it travels in fluids like liquids and gases. In a longitudinal wave, the particles of a medium are displaced in a direction that is parallel to the direction of the propagation of a sound wave. In other words, the sound wave and the moving particles of a medium are in the same direction. That is why it is called longitudinal wave. In solid medium, sound travels in the form of both longitudinal and transverse wave while passing through solids like rocks and fiberglass. In a transverse wave, the particles of a medium are displaced perpendicular to the direction of the propagation of a sound wave. In a solid, molecules are compact, sort like they are holding hands with their neighboring molecules, wherein in fluids they do not. And this enables sound to move in transverse waves in a solid medium. Again, in solid medium, sound travels in the form of both longitudinal and transverse wave while passing through rocks and fiberglass and other solids. In a medium, sound moves with a series of compression and rarefaction. When we say compression, it is a region in a medium where the particles are closest, and the rarefaction is the region where the particles are farthest apart. Compression and rarefaction are the result of vibration where the particles move fast in a forward and backward motion. Now, what is a speed of sound? The speed of sound is the distance traveled per unit of time by a sound wave as it propagates through an elastic medium. Now, let's study the factors affecting the speed of sound. What are the factors affecting the speed of sound? The speed of sound differs because it is dependent on number 1, the type of medium, and number 2, the temperature of a medium. Again, when we say medium, it is a substance through which sound travels. How does type of a medium affect speed of sound? The speed of sound is affected by the elasticity and density of a medium. Take note, the speed of sound is affected by the elasticity and density of a medium. Elasticity is the ability of matter to maintain its shape and size when a force is applied on it. Elasticity also measures the tendency of material to resist deformation. On the other hand, density describes the mass per volume. In general, sound travels faster through media with higher elasticity and lower density. Now, why does sound travel faster in more elastic medium? In more elastic medium, particles return to their resting position quickly and are ready to move again more quickly. Thus, they can vibrate at higher speeds. Therefore, sound can travel faster through mediums with higher elastic properties like steel. Sound can travel faster through mediums that vibrate faster, and this is the characteristic of an elastic medium. And why does sound travel slower in denser material or in a material with higher density? Why is this so? If the material is more dense, because its molecules are larger, it will transmit sound slower because it takes more energy to make large molecules vibrate. Thus, sound will travel at slower rate in more dense medium or object. In materials of the same phase, the more dense the material, the slower the waves travel. So remember, in a denser medium or in a denser material, it takes more energy to make large molecules vibrate, so the sound travels at slower rate or at slower speed. Mathematically, the speed of sound in different media is computed as equal to the square root of the elasticity of a medium or material divided by the density of medium. Again, the formula for the computation of the speed of sound in different media is equal to the square root of the elasticity of medium divided by the density of medium. This equation or formula is valid for liquids, solids, and gases. Based on the given formula, so it is noted that the elasticity of the medium is directly proportional to the speed of sound, and density is inversely proportional to the speed of sound, meaning the sound travels faster through medium with higher elasticity and medium with lower density. So meaning the higher the elasticity of a medium, the faster the sound travels. The lower the elasticity, the slower the sound travels. The lower the density, the faster the sound travels. And the higher the density, the slower the sound travels. Now let's proceed to the second factor that affects the speed of sound, which is the temperature of a medium. How does temperature of a medium affect speed of sound? At higher temperatures, air molecules have more energy, which means they vibrate faster, and this allows the sound wave to also travel faster because they are propelled by the collision between the molecules. At lower temperature, air molecules have less energy, which means they vibrate slower, and this allows the sound wave to travel slower because they are propelled by the collision between the molecules. This is the reason why sound travels faster in hot air than cold air due to increase in speed of the moving particles in hot air. As stated by kinetic molecular theory, when particles absorb heat, their kinetic energy increases, allowing them to move faster. And this is the reason why it takes less time for sound to reach our ears due to greater collision and vibration of molecules during hot days or summer seasons. During summer season, air temperature increases. At higher temperature, the molecules of air have more kinetic energy. As a result, they vibrate faster, leading to the increase in the speed of sound. Now, during winter season, the temperature of air decreases. With a decrease in temperature, the kinetic energy of the molecules also decreases. As a result, the molecules do not vibrate much. So, the speed of sound decreases during the winter season. Now you know why sound travels faster in summer than in winter. To calculate the speed of sound in air, that is equal to speed of sound in dry air plus the quantity 0.6 meter per second times the given temperature in a certain problem. Again, the formula for the speed of sound in air is equal to the speed of sound in dry air plus the quantity 0.6 meter per second times the given temperature in a problem. Take note, in dry air, which is at 0 degrees Celsius, the speed of sound is 331 meters per second. Again, in dry air, at 0 degrees Celsius, the speed of sound is 331 meters per second. And the speed of sound increases by 0.6 meter per second with every increase of 1 degree Celsius. Again, the speed of sound increases by 0.6 meter per second with every increase of 1 degree Celsius. So let's try this problem. What is the speed of sound in the air if the temperature is 30 degrees Celsius? Again, what is the speed of sound in the air if the temperature is 30 degrees Celsius? Okay, to solve this one, we simply substitute the information in the formula, which is the speed of sound in air is equal to the speed of sound in dry air, which is 331 meters per second, plus the quantity 0.6 meter per second times the given temperature in the problem, which is 30 degrees. In solving problem involving grouping symbols, first, we need to simplify or to solve first the quantity in a grouping symbol such as the parentheses, the bracket, and etc. In this problem, so we have the quantity 0.6 meter per second per degree Celsius times the given temperature, which is 30 degrees Celsius. So when we multiply this one, the result is 18 meters per second. So we cancel now the degree Celsius. Then, after that, we add the 18 meter per second to the speed of sound in dry air, which is 331 meters per second. And the result is 349 meters per second. So this is the speed of sound in the air when the temperature is 30 degrees. Let's try to have another sample problem. What is the speed of sound in the air if the temperature is 20 degrees Celsius? Again, what is the speed of sound in the air if the temperature is 20 degrees Celsius? This time, the temperature is 20 degrees Celsius, which is far lower than our first example. So, to compute for the speed of sound, that is equal to the speed of sound in dry air plus the quantity 0.6 meters per second per degree Celsius times the given temperature, which is the 20 degrees Celsius. So first, we multiply the data within the quantity, which is 0.6 meters per second per degree Celsius times the 20 degrees Celsius temperature. And the result is 12 meters per second. So again, we cancel the unit Celsius here. Then after that, we add this one to the speed of sound in dry air, which is the 331 meters per second. So 331 meters per second plus 12 meters per second. The result is 343 meters per second. So take note, at 30 degrees Celsius, the speed of sound in air is 349 meters per second. And at 20 degrees Celsius, the speed of sound in air is equal to 343 meters per second. So, as we can see, at lower temperature, the speed of sound is lower. At higher temperature, the speed of sound is higher. So, temperature really affects the speed of sound in air. Other than temperature, there are also other factors that affect the speed of sound, such as air pressure, air humidity, and wind direction. Generally, the higher the air pressure, the faster the sound travels. The higher the air humidity, the faster the sound travels. And when the wind direction is parallel to the direction of the sound wave, the faster the sound travels. And when the wind direction is opposite to the direction of the sound wave, the slower the sound travels. Sounds help us enjoy and identify things around us. Whether it is sound of birds, sound of musical instruments, the voice of our neighbors, or even typing on a keyboard, our brain processes a lot of information just by sound. But there's so much more to sound than our own sense of hearing. So students, let's get to know some interesting facts about sounds which we might have never known. First, our ears vibrate in a similar way to the original source of the vibration, allowing us to hear many different sounds. Second, dogs can hear sound at higher frequency than humans, allowing them to hear noises that we can't hear. Sound is used by many animals to detect danger, warning them of possible attacks before they happen. The scientific study of sound waves is known as acoustics. The sound of thunder is produced by rapidly heated air surrounding lightning, which expands faster than the speed of sound. Sea lions hear better underwater than on land because sound waves travels 4 times faster through water than air. People hear sounds that vibrate between 20 and 20,000 times in a second. Bats hear sounds that vibrate up to 200,000 times a second. Sounds with higher frequency than humans can hear are called ultrasounds. Dogs, cats, dolphins, and mice can hear ultrasounds. Certain crickets, moths, and frogs make and hear ultrasounds too. Infrasound are low-frequency sound below the hearing range of 20 Hz. Horror films like to use infrasound, which is below the range of human hearing. This sound creates shivering, anxiety, and even heart palpitations in humans when it is being played. The loudness of sound depends on the intensity and also on the sensitivity of our ears. How do our ears respond to sound? How do our ears respond to sound? First, we have the outer ear. In the outer ear, sound waves travel down the inner canal to the eardrum, which vibrates in response. Then the middle ear, we have 3 bones there, small bones, the hammer, the anvil, and the stirrup, which transfer the vibration to the inner ear. Then the inner ear contains the cochlea, which transforms the vibrational energy to electrical energy and sends signal to our brain. And our brain interprets the sound or the kind of sound that we hear. To check our understanding of this lesson, let's answer this one, true or false. Number 1, sound travels in a vacuum. True or false? The answer is false. Sound does not travel through a vacuum. Remember, sound is a mechanical wave which requires a medium. Number 2, sound needs a medium. True or false? The answer is true. Sound needs a medium because it is a mechanical wave. It cannot transfer energy without particles in a medium, so it requires a medium. Number 3, the higher the temperature, the faster the speed of sound. This is true because at higher temperature, the greater the vibration, the greater the molecular collision, so the faster the sound travels. Okay, number 4, sound moves slower in elastic materials. Is this true or false? The answer is false. The truth is sound moves faster in more elastic materials because elastic materials allow the particles to vibrate faster. So that makes sound travels faster. Fifth, we hear sound in outer space. This is false. We cannot hear sound in outer space because outer space is a vacuum. Number 6, sound is a mechanical wave. So this is a big true because sound transfers energy through particles in a medium. That is why it is called a mechanical wave. 7, sound is a longitudinal wave. This is true. In fluids like gases and liquids, sounds behave as longitudinal wave. In solids, sounds behave both as longitudinal wave and transverse wave. Number 8, elastic medium vibrates in greater speed. This is true. Number 9, sound travels fastest in gases. This is false. In gases, remember the particles or the molecules are very far apart, and this results to lower molecular collision or vibration that makes sound travels slower. Number 10, sound moves through hot air faster than in cold air. So this is true. In hot air, molecules have more kinetic energy and they vibrate faster, and so that makes sound travels faster. This is all for today, students, for our science lesson. Thank you very much for your time. For this RBI segment, thank you DepEd Dapitan City, headed by our Superintendent, Dr. Felix Romy Triangolo, and thank you LGU Dapitan City, headed by the City Mayor, Honorable Rosalina Garcia Haloshos. For your queries, clarifications, and suggestions, you can do an email on this address, fsherry2017@gmail.com. Grade 9 students, if you need more information and want to learn more, you can go to my YouTube channel, Sherry May Fernandez, for more educational videos about our lesson, Factors Affecting the Speed of Sound. Rise and shine, Educalidad. Stay safe everyone. Bye-bye.